practice some questions on ionic equilibrium. Let's look at first example. It says dissociation constant of acetic acid. Acetic acid is a weak acid. Its dissociation constant means its Ka value is written as x into 10 raised to minus 5, and we are supposed to find the value of x. There is some data given in between. We have to find this value of x. Okay, so question says we mix two things, a salt, sodium acetate, with acetic acid. Acetic acid is a weak acid, sodium acetate is salt of weak acid. The mixture of these two may be a buffer. Okay, so for buffer we use Henderson's equation, pH equals pKa plus log concentration of salt divided by concentration of the acid. Now we'll put the given values, okay, and try to find the pK and hence Ka. pH of this solution is given as 5. Concentration of salt 0.2, concentration of acid 0.02. The ratio of these two is 10, so I can now write 5 equals pKa plus log 10. Log 10, I hope everyone knows, is 1. So from here you will get pKa equal to 4. Hence the value of Ka is 10 raised to minus 4, which can be written as 10 into 10 raised to minus 5 as specified in the question, x into 10 raised to minus 5. So you compare and you get the value of x as 10. This is the answer. Okay. We'll now see another example. The question says if pKa value of lactic acid is a weak acid. This is lactic acid. It's a alpha hydroxy carboxylic acid. It's a weak acid. Its pKa value is given as 5. Okay. Then we have to find the pH of 0.005 molar calcium lactate. Calcium lactate is salt of a weak acid. Okay. So if I represent this lactic acid as, so it's calcium salt, I can represent like this in short. Okay. So when we take calcium salt of lactic acid, it ionizes like this. This salt, calcium lactate, which is salt of weak acid, lactic acid, and strong base calcium hydroxide, this salt on hydrolysis undergoes anion hydrolysis. Due to anion hydrolysis, pH is given by this formula. You must have done, everyone. This is how you evaluate pH of a salt of weak acid and strong base. Here C denotes concentration of anion which undergoes hydrolysis. Okay, so this will be concentration of lactate ion that we have to find. What we are given is 0.005 molar. If this is 0.5 molar concentration of salt, it dissociates and produces 0.005 here, and 2 into, which means 10 raised to minus 2 molar is a concentration of lactate ion once ionization is complete. Okay, so let's put in the values here. Okay, pH equals half, pK water value is 14, pK is given as 5 plus log C means log of 10 raised to minus 2. So we get 19 minus 2, so pH is 8.5. Now in the given format, answer is written as x into 10 raised to minus 5 minus 1, so I can write like this. Compare these two, x would be 85, which is answer to this question. Okay, it's an easy question, just you need to take care that this is the relevant formula, and here C is concentration of lactate ion, it's not concentration of the calcium salt. So you need to find concentration of lactate ion, put it here and then evaluate. Okay, let's see another example. The question says we have a liter of, means we have 1 liter of buffer solution which has two components, ammonia which is a weak base and its salt. Weak base plus its salt, this mixture is a basic buffer. Okay, then HCl is added into it in some amount. HCl is added. So when you add HCl, this is a reaction that takes place. HCl reacts with the basic compound ammonia. Now the moles given are 0.1, 0.1 and HCl added 0.02. Okay. Of these two, this is in smaller amounts, so will act as a limiting reactant. Finally is consumed. It reacts with 0.02 moles of ammonia, so 0.08 moles are left, and 0.02 moles of ammonium chloride would be produced, so total mole will become 0.12. So this final composition indicates you have a weak base ammonia and its salt present. So this mixture should act as a basic buffer. I can use Henderson equation, POH equals PKB plus log salt upon base. Okay. Now let's put the given values. PKB is given as 4.745 and the other values 0.12 by 0.08. That gives me 4.745 plus log 3 by 2. Okay, so I'll draw a little portion to complete it. See, the values of log are given in the question, so we'll have to substitute these values. I can now write this as log 3 minus log 2. Rest is calculation. Okay, rest is calculation, not difficult. You evaluate pH like this, then pH should be equal to 14 minus 4.9 to 1. Okay, 14 minus 9 to 1 is approximately like this. We get pH. Now question says pH should be written in this format, x into 10 raised to minus, so I can write 9079 into 10 raised to minus 3. So this is the value of x. Okay, let's try another example. Okay, let's see another example. Here we have HCl being mixed with sulfuric acid. Both are acids, both will provide H plus ions. So H plus ion final concentration can be written as H plus coming from solution 1 into volume plus H plus coming from solution 2 into V2, but H2 is a 4 is diprotic, so we'll have to write 2 here. It produces 2 H plus ions per molecule divided by the total volume. This will give me the final concentration of H plus in the solution. Let's put the values. 600 this should do 10 raised to minus 3. This is H plus final. Okay. Now we need pH of the solution would be minus log H plus. So minus log 14 into 10 raised to minus 3. 3 minus log 14. Okay. Which can be written as 7 into 2. So I can write log 7 minus log 2. Rub a little part here. We got pH as 3 minus log 7 minus log 2. And okay, so I think this will give you the final pH value. 0.86 can be written as 186 into 10 raised to minus 2. Okay, now compare with the given format, the value of x is 186. That's the answer. Okay, we'll see more examples in the next lecture.